Hello everyone, my name is James Ekpa and I'm a former student at the Center of Excellence for Data Science, Artificial Intelligence and Modeling, otherwise known as DAME. And currently I'm working as a research assistant in Artificial Intelligence for Systematic Reviewing at the Center of Addiction and Mental Health Research, otherwise known as CAMHR, here at the University of Hull. We're here for another episode of the Project Spotlight series, and with me today is Joseph, and I'll let him introduce himself.
Hi guys, my name is Joseph Ogbole. I'm also a recent graduate of AI and Data Science from DAME, and I've been invited to speak about my project today.
Thank you so much, Joseph. We're pleased to have you here with us today.
Happy to be here, bro.
Yeah, so let's go into our first question. So let's start by knowing the title of your project and what inspired you to choose this project in AI and Data Science.
So the title of my project is Multimodal Sign Language Detection. And it's actually rooted in some of my experiences growing up, why I chose the topic. Because growing up, I used to have classmates that had issues with their hearing.
Yeah.
Some of them were deaf.
Wow.
And I saw how they struggled to tag along with us in class. And then getting to the point where I have this experience in artificial intelligence and data science put me in a position where I could actually do something about that, So my project, my primary motivation is AI for good, AI for inclusivity, and AI for social impact. So
interesting.
Yeah,
that's very interesting. So let's move to the next question, which is a brief overview of the project and its aims and objective. I know you have touched this in the previous question, but let's give us a brief overview of the project.
Okay, so
Hello, I'm Dr. Daniel Farrow here at the Center of Excellence for Data Science, AI and Modeling at the University of Hull. AI is changing the way that big organizations operate, and that's why we're really excited to be launching a new MSc this January, Artificial Intelligence for Business. Alongside the same great content that we teach in all of our MScs, like Python programming and data science, we have two bespoke modules for this MSc about how to use AI and data in a business context. In AI for Marketing and Sales, our first bespoke module, you'll learn things like how to use chatbots for customer engagement, how to do dynamic pricing. You'll learn about an important concept called customer segmentation. You'll learn about recommendation engines, and you'll also learn advanced topics like sentiment analysis and natural language processing. In the other bespoke module, Big Data for Business, you'll learn an introduction to big data, a key thing in business. You'll learn exploratory and causal analytics, different platforms for storing big data in business, data mining and web scraping, applications of big data in business, and also time series analysis for business contexts. In your third trimester, you'll get to do an original project under the supervision of one of our members of staff. This course is open to a wide variety of people from different backgrounds. You don't necessarily need a science degree as a conversion course, where the ideal option for people who are looking for a career change, for example. Please, we're really looking forward to you joining us in this £4.5 million teaching facility here in the DAME Lab. And I'd also like to highlight that our teaching was rated gold in the last Teaching Excellence Framework 2023. If you have any more questions or want specific information about the entry requirements for this course, then I would recommend you check out the website.
Start with the aim and the objective of the project. So, as I mentioned, there are deaf people, over millions in the world, and they struggle with communication. So the aim of my project is to build a system that can make that interactive end-to-end conversation smooth between deaf people and non-deaf people. Imagine if that could be possible. Imagine you were deaf and I wasn't, and we had to communicate. If I didn't know sign language, how would we make that happen? It would be almost impossible. So the goal of my project was to build a system that could break that barrier between deaf people and non-deaf people. So I built a multimodal sign language system that combines both RGB points and key points based on post-based systems.
Okay.
So yeah, that's what we did.
Thank you so much. Thank you so much. So let's talk about the technical aspect as well. So what specific AI and data science techniques did you use in this project, and why did you use them?
So the approach I used for the project was a very comparative one. So while I had my goal in mind, I also needed to do a lot of comparative analysis to know which models and which techniques to use.
What's best, yeah.
So like I said, the project combines two streams. It uses both RGB and post-based key points because RGB has its own issues. Like it's very sensitive to lighting, it's very sensitive to background noise, but it captures fine details. Key points, on the other hand, does not capture fine details, but is very robust when it comes to background noise. So my thought was, how could I combine the strengths from these two streams to produce a more robust and reliable system? So to do that, I compared 4 models, 2 for the RGB stream and 2 for the key point stream. For the RGB stream, I used the Resonate 18 backbone combined with the transformer and the temporal CNN. So why I used the transformer was because of its self-attention module. So it makes it very reliable when it comes to predicting sequential data. So, you know, RGB, the frames in RGB are sequential, so that was why I used transformer. And for the key point, I also used a transformer head as well. Yeah, so while I did that, there was a module that involved like fusing those 2 models, the RGB and the key point. To make that happen, I used calibrated fusion. So what that does is it takes the softmax function for prediction and it adds a new mathematical term to it, T. So what T does, it calibrates the stream for key points and that for RGB, so that the predictions from one stream does not overpower the prediction for the other. So it sort of like balances the predictions. So yeah.
That's great. But I'm just to follow up questions, you know, putting this all together, this is a lot of technicalities, right, to understand. And putting all this together, how does it come together to aiding the individual who is deaf, you know? So is it that you build an assistant, a virtual assistant?
What we've talked about now is the model side of things. So to make this system truly interactive, we have to integrate it to systems like phones. We have to integrate it to systems like smart glasses. We have to integrate it with systems like TV and broadcasting, so that when people communicate, like, it's a good thing you have your glasses on now. Imagine I did something in sign language. When we integrate the system to your glass will translate what I just signed to you in text, in whatever language you speak, whatever language you set it to. So that's another beautiful facet of the project we are working on, multi-platform integration. So we aren't just going to integrate it to, or leave it as a basic model. We're actually going to integrate it to systems like smart glasses, like we've mentioned, your phone, so that you could have end-to-end conversation with someone that is that in real time. So
and then that's what translated in text, and you could read it and understand what the person is talking about.
That's another thing, multimodality. We're talking text, we're talking speech, and we're talking signs. So there's a lot of facets to the project. That's what makes it beautiful.
That's very interesting. So yeah, let's move on to the next question. You know, every project has its own hurdles, right? And there would have been a lot of challenges you would have gone through in terms of, you know, your analysis and even data gathering. So I would like to know, what are the challenges you faced during this project and how did you overcome them?
The singular most important challenge we faced during this project was data collection.
Always a challenge.
Yeah.
And for a project like this, data collection will be a challenge.
Yeah. So it's a very complex project, because to translate sign, you need to not only capture the signs the people are making, you need to capture the language as well, and you need to capture transition. When people sign from one transition to the other, you need to be able to capture those nuances. And unlike spoken language, there is a lot of nuances that goes into sign language. Sometimes a word can have
context and understanding.
Exactly. A word can have, or a sentence can have a different meaning from the facial expression the signer has. So I could sign 2 equal signs, but a different facial expression might change the entire meaning of the sentence I've just made. So we needed to find data sets that captured those nuances in sign language. So what made that possible for us to do was to gather data from different sources. We got the WLASL data set, we got the how to sign data set, and we incorporated all of them to be able to make this possible. So
that's very interesting.
Yeah.
And the data cleaning and pre-processing aspect would have been a whole lot of work to do.
Most of the job went into that, like gathering the data, putting them together, trying to isolate each sign, and then capture that temporal dependency in translation and transition and all of that. So yeah.
That's very interesting. Well done.
Thank you.
So let's think about the bigger picture, right? So how do you think this project could impact the real world problems and also the industry? How does it affect the industry?
Like